What up guys, it's TechTutorialsz here back with another video, and in this video I'll be showing you how to prove the product rule in calculus. So basically, to prove the product rule, we're going to be using the definition of a derivative. You've already seen the definition of a derivative. Using that, we're going to prove the product rule, which is basically a function times another function, which is equal to the derivative of the function times the second function plus the derivative of the second function times the normal function. In order to do this, what we'll do is we're going to set a condition. And our condition is going to be let f of x, capital F of x, equal to f of x times g of x. Alright, so that's going to be our condition. So now to start off, is the first step is going to be using the definition of a derivative. Right, so I'm just going to write that down quickly. Right, so I'm just going to copy everything from the top, except I'm going to use my condition for the definition of the derivative. Over delta x, right? My bad. So over delta x, right? So what we're gonna do is just we're gonna substitute whatever we set the condition to back to f of x, the lowercase f of x, g of x. So we're just gonna substitute that back in. I'm just substituting whatever's on top back in. So my condition, I'm just putting that back in. Alright. So once this is done, we're going to do something to manipulate the equation. We have to do something in order for this to work out. What we're going to do is you're going to see it in a bit. So what I'm going to do right now is I'm basically just copying everything from the top, hence the arrow. And this is the manipulation that I'm going to do. So I'm going to plus f of x plus delta x and g of x, and I'm also going to minus the same thing, f of x plus delta x, g of x. So I'm just going to write a note. So basically what this is basically there to manipulate the equation. Right, so if you don't know, basically f of x plus delta x, g of x, and then minus the same thing, it's there, it also equals 0. So it doesn't affect the equation whatsoever. It's just there to manipulate the equation in our favor and make sure to put it over delta x. So now we're going to continue over to writing the rest of the proof. So in order to write the rest of the proof, what we're going to do is we're going to break the limit up into 2. And we're going to take out which one we have to take out. So first of all, I'm going to take out f of x plus delta x. My bad. I'm going to take out f of x plus delta x, g of x plus delta x, right? Which is the first one. And then I'll also minus it with the last one, which is f of x plus delta x, g of x. This is the one that I used to manipulate. And I'm just going to put that over delta x. And now using the property of limit, because I could break the limits, I'm just going to add another limit. Right, delta x approaches 0, and I'm going to do this the third one on top, right above, and subtracting the second element. Right, I hope you can see what I just did there. I just broke it up, and I just put two from the first to the last, and I put the third to the second together to break the limit up into 2. And now from this, we have to look at what is there in common. So is there something in common? We see that f of x plus delta x is the one in common. So what I do is I'm just going to rewrite this equation. And I see that f of x plus delta x is in common, so I'm just going to take that out. And what's multiplied with that is basically g of x plus delta x minus g of x. And then make sure to always put it over delta x, of course. And I'm going to do the same thing for here. So what is common in here? We see that g of x is common in here. So we'll be multiplying that with f of x plus delta x, whatever that's multiplying by with, minus f of x. And you could put that all over delta x. So when we look at this, we have to look at the limits, right? Looking at the limits, we see delta x approaches 0. So we take this delta x, right? And this approaches 0. So that means this f of x becomes a constant because delta x has no play in this. And we do the same thing for, does delta x approach anything? Well, it approaches 0 and delta x is only here and here, but if it's 0 on the denominator, then it goes towards infinity. So we cannot do that. Then our g of x is constant in this direction. So what this gives us, finally, we're going to take the constant out of f of x, right? So we're going to take it out, f of x, right? And we're going to bring the limit inside, right, according to properties of limits. So this will be g of x plus delta x minus g of x all over delta x. And we're going to do the same thing here by taking out this constant function, which is g of x times the limit as delta x approaches 0. And I'm just going to copy this over here. So all over delta x. Alright, so basically we're done. So just for you to see it, this is f of x, right? We just leave that. This whole thing, the definition of a derivative gives us the derivative of that function, right? Plus this constant, right? G of x, and then multiplied by the definition of derivative of this function, which is f prime x. So this right here, it has been proven, right? So it has been proven. This is the proof. So the derivative, right? So the derivative of f of x times g of x is equal to this thing.